The red planet Mars has captivated humanity's imagination for centuries. Once, we gazed at it as a distant, enigmatic neighbor. Now we see it as a potential future home. Recent advancements in space technology have reignited our fascination with Mars, making colonization a tangible possibility rather than a science fiction fantasy. Private companies and government agencies are investing heavily in research and development, pushing the boundaries of space exploration and bringing us closer to the reality of humans on Mars. The allure of Mars lies not just in scientific curiosity, but also in the profound implications it holds for humanity's future. As we grapple with overpopulation, resource depletion, and climate change on Earth, Mars presents a potential escape valve, a blank canvas upon which we might rewrite the story of our species. However, colonizing Mars will be a monumental undertaking, fraught with complex challenges that demand innovative solutions. The first hurdle in our Martian endeavor is developing reliable and efficient interplanetary transportation. While we have successfully sent robotic missions to Mars, transporting humans presents a whole new set of challenges. The journey itself would take approximately 7 months, exposing astronauts to prolonged microgravity, cosmic radiation, and psychological stress. To address these challenges, scientists and engineers are working on developing new propulsion systems, such as nuclear thermal or ion propulsion, to reduce travel time. Advanced spacecraft designs, incorporating artificial gravity and radiation shielding, are being explored to ensure the safety and well-being of the Martian pioneers during their long journey. Furthermore, efficient life support systems capable of recycling air, water and waste are crucial for long-duration space missions. Once on Martian soil, the next challenge lies in establishing a self-sustaining colony. The Martian environment is harsh and unforgiving, characterized by a thin atmosphere, frigid temperatures and intense radiation. To survive, colonists will need to create a habitable environment that provides protection from the elements and allows for the cultivation of food and the production of essential resources. Initial habitats will likely be built underground or within existing Martian caves, offering natural shielding from radiation and temperature extremes. These habitats will need to be pressurized and heated, creating an Earth-like atmosphere where humans can live and work comfortably. As the colony grows, 3D printing technology could be employed to construct larger structures from Martian regolith, the loose, unconsolidated rock and dust found on the planet's surface. One of the most critical aspects of establishing a permanent Martian colony is creating a breathable atmosphere. Mars's atmosphere is incredibly thin, composed primarily of carbon dioxide, and offers little protection from solar radiation. To address this, scientists are investigating a process called terraforming, which involves altering the Martian environment to make it more Earth-like. Terraforming Mars would be a monumental task, potentially taking centuries to achieve. It would involve releasing greenhouse gases into the atmosphere to trap heat, melting the polar ice caps to release water vapor, and introducing photosynthetic organisms to generate oxygen. While terraforming is a long-term goal, initial efforts will likely focus on creating localized, controlled environments within habitats where humans can live and work without spacesuits. Sustaining a human presence on Mars requires a reliable food supply. Transporting food from Earth would be impractical and costly, making it essential to develop sustainable agricultural practices on Mars. Martian soil, however, lacks the essential nutrients and microorganisms necessary for plant growth. To overcome this challenge, scientists are exploring innovative agricultural techniques such as hydroponics and aeroponics, which grow plants in water or air, respectively, without the need for soil. These methods can be used in conjunction with genetically modified crops, specifically engineered to thrive in Martian conditions. Waste products from human inhabitants could be utilized as fertilizer, further enhancing the sustainability of Martian agriculture. One of the most significant threats to human health on Mars is the high level of radiation. Unlike Earth, Mars lacks a global magnetic field and a thick atmosphere to deflect harmful cosmic rays and solar flares. Prolonged exposure to this radiation can damage DNA, increasing the risk of cancer and other health problems. Protecting Martian colonists from radiation will require a multi-pronged approach. Habitats will need to be constructed with radiation-resistant materials, and underground shelters will be essential for protection during solar storms. Scientists are also exploring the use of artificial magnetic fields and radiation-absorbing materials to create a protective shield around habitats and spacecraft. In addition, specialized medications and dietary supplements could help mitigate the harmful effects of radiation exposure. Artificial intelligence and robotics will play a pivotal role in every aspect of Martian colonization, from constructing habitats and conducting scientific research to operating life support systems and even assisting with medical care. AI-powered rovers and drones can explore the Martian terrain, gather valuable data, and even prepare infrastructure ahead of human arrival. AI systems can monitor and adjust life support parameters in real time, ensuring a safe and stable environment within habitats. They can also analyze vast amounts of data to optimize resource utilization, identify potential hazards, and assist in decision-making processes. By automating tasks and providing critical support, AI will enable human colonists to focus on exploration, research, and building a new society on Mars. As we venture into this uncharted territory, it is crucial to consider the ethical implications of colonizing another planet. The potential for contaminating Mars with Earth-based life, intentionally or unintentionally, raises concerns about preserving the planet's pristine environment and the possibility of discovering indigenous Martian life. Strict planetary protection protocols will be essential to prevent forward contamination, ensuring that any scientific exploration or colonization efforts do not compromise the search for past or present life on Mars. Additionally, ethical guidelines for resource utilization, waste management, and the potential terraforming of the planet will need to be established to ensure the long-term sustainability and responsible stewardship of our Martian endeavors. Colonizing Mars is not merely a technological challenge, but a profound cultural and philosophical undertaking. It represents a new chapter in human history, an opportunity to learn from our past mistakes and create a more sustainable and equitable future for our species. The challenges of living on Mars will foster innovation and collaboration on an unprecedented scale, pushing the boundaries of human ingenuity and resilience. The Martian frontier will offer new perspectives on our place in the cosmos, prompting us to re-examine our relationship with Earth and each other. As we strive to create a new home on Mars, we will inevitably gain a deeper understanding of ourselves, our planet, and the preciousness of life in the universe. The prospect of colonizing Mars is both daunting and exhilarating. The challenges are immense, demanding groundbreaking technological advancements, unwavering human spirit, and a profound sense of responsibility for the red planet we seek to inhabit. However, the potential rewards are equally significant, offering a chance to ensure the survival of our species, expand our understanding of the universe, and inspire generations to come. As we venture further into the cosmos, the whispers of the red planet beckon us to explore, to innovate and to dream of a future where humanity becomes an interplanetary species. The journey to Mars will be long and arduous, but the destination holds the promise of a new dawn for humankind.